Hi, my name is Martin, and I'm going to be taking you through the Python for Finance course. I have a degree in economic and social sciences, with a strong focus on quantitative methods and econometric models. I am a quant enthusiast, and the world of data science fascinates me. So it is a complete pleasure to be your Python teacher in this course. Given that the course is composed of two main blocks, coding in Python and finance, I am very happy to have a co-instructor who will help me with the finance topics. So, I would like to present to you my colleague Ned, who will be helping us with the finance part of the course.
Hi there, and a warm welcome to 365 Careers Python for Finance course. I'm Ned, and I have a master's in finance degree. I have also gained practical experience working as a financial advisory consultant with PwC and as a financial analyst with Coca-Cola. I enjoy teaching, having taught over 50,000 students here on Udemy. I'll be more than happy to join in the second part of the course and explain the theory behind all of the finance topics we will solve in Python. And, in fact, this course is the perfect one-stop shop for those of you who would like to learn how to code in Python and how to use Python for the purposes of financial and investment analysis. Everything we will study has a real-world application. Get excited, as you've come to the right place and at the right time. Martin, shall we take a look at the course content?
Definitely. Let's take a look at what you can expect to see next. First, we'll learn the very basics of Python, one of the most widely used programming languages in the world today. This part of the course is fundamental for those of you who don't have previous experience in coding or need a quick refresher. No need to worry though. Everything's made really easy with a lot of examples and clear explanations. We will learn about Python syntax, data types, operators, conditional statements, functions, lists, tuples, dictionaries, loops, and more. Then, once we've laid a solid foundation, we'll be ready to start learning about some more advanced Python techniques. For example, in these lessons, we will teach you what object-oriented programming is about and how to import libraries and modules useful for doing financial analysis in Python. Besides being introduced to working with arrays, you will see how to load and organize your data, a crucial tool for any data analytical job.
Okay, once we have covered these chapters, we will be ready to dive into the second part of the course, which is truly awesome. You will learn about stock returns, risk, how to form investment portfolios, how to calculate the risk and return of investment portfolios, how to calculate the correlation between financial securities, and how to diversify a portfolio. What is a regression, and which are its components? In addition, we'll cover Markowitz's efficient frontier analysis, and we'll learn how to verify if a portfolio lies in the efficient frontier. What is a stock's beta, and how it influences the desired rate of return from investors, and how to apply the CAPM in practice. Sounds amazing, right? Wait, we're not done yet. We'll also learn how to work with multivariate regressions and how to perform Monte Carlo simulations. In fact, we will do 3 Monte Carlo simulations, one in a corporate finance context, another in order to estimate the price of a stock option, and then a third in order to price a stock. You will learn how to do all of this. The approach we use makes everything really easy to understand. First, I will explain to you the finance theory that you need in order to understand a given concept, and then Martin will show you how we can apply that theory in practice using Python.
To get the most out of this course, please don't skip any lectures, as we will gradually build on your knowledge and the concepts you will learn in the first part of the course will be useful later on. The lessons in this course contain a number of downloadable resources that will help you reinforce what you have learned. Course notes, exercise files, PDF materials, handy notebook files, everything is included and can be downloaded easily. Feel free to post in the course discussion board when you experience some difficulties, would like to ask a question, or simply want to share something with the community. This course is an amazing adventure, and on top of that, you will get free access to 2 of our other courses, Beginner to Pro and PowerPoint, provided that you complete 50% of the course, and the Power Modeling Bootcamp, Advanced Excel in 10 days. provided that you complete 100% of the course. Are you excited? Awesome! Dive straight in and let's begin this journey together. There are a number of downloadable materials you will find attached to most lectures in this course. They will allow you to practice and reinforce what you have seen in the lessons. The three main types of resources we have prepared are course notes, available at the beginning of each major block of the course, quizzes that will pop up once you start watching the videos, and exercise files. Of course, the exercise files are in a specific file format, an IPython notebook document.ipynb. You will be able to download these files on your computer quite easily. However, you won't be able to open them without a specific software. Don't worry, a few lessons from now, we'll show you how to download the Anaconda package with which you will be able to open and work with these files. As far as downloading goes, there are two main ways to do it. If you would like to download the entire set of exercises and course materials at once, you can use the Dropbox link at the beginning of the course. Once you've opened it, you'll be able to download the complete set of files. They are organized in folders, and each folder contains the respective exercises. If you are opting for this method, assign a directory where you would like to save these files. Click on Save, and after the materials have been saved on your computer, you will be able to find them in the designated folder. The other download option is to use the links provided with each video. For example, below the variables lesson, I can see a link to the exercise document. After I click on it, I will be able to download a single notebook file. I can easily save the file on my desktop. You see? The file is here. Just a few videos from now, you will learn how to use the software that can open these files. Regardless of the way you decide to download these files, it is quite important that you use them and don't skip them. Solving the exercise files is the best way to verify you have acquired new techniques and skills. Furthermore, when you ask experienced programmers, they will always tell you that unless you exercise and apply programming in practice, you will not make significant progress. And hey, if you feel like you missed a step along the way, feel free to rewind the videos or rerun the notebooks. If this does not help, we will be happy to respond to your questions in the Q&A section. Just drop us a line. We are always happy to hear from you. All right, what do you need to know about programming if you are just getting started? We all have to deal with certain tasks in our daily lives. Many we can solve on our own, while others, especially the ones that are more complicated, can be solved with the help of a computer. Assume you have defined a problem that must be solved and you know the steps that must be taken to solve it. Even if you could structure your logic perfectly and type a brilliant solution in English, the computer will not understand it, as it understands zeros and ones only. No other symbols. Similar to a light switch, it recognizes two phases, on and off. To communicate a real-life problem to the computer, you need to create a specific type of text called a source code or a human-readable code that software can read and then process to the computer in zeros and ones. A program is a sequence of instructions that designate how to execute a computation. Therefore, the formal definition of programming is the following: taking a task and writing it down in a programming language that the computer can understand and execute. You need not be a geek or computer scientist to program. Actually, the subject of computer science is not the study of programming. These are different things, and this can confuse beginners. Computer science is about understanding what computers can do. Programming, instead, is the activity of telling computers to do something for us. Think about the world we live in today. There are more than 1,000 programming languages out there, and each language is designed for carrying out specific tasks. So, depending on the sphere to which your problem applies, only some languages can be of good use. For instance, PHP is good for web programming, but is not suitable for programming devices. C++ can definitely help you with the latter, while Python and R are some of the favorite tools of data scientists and people from the finance industry. When you meet an experienced programmer, don't think he can program in all languages out there. Instead, it is likely he can work with one or maybe a few languages, but he has mastered them well. Right, but how does somebody become good at programming? First, programming requires problem-solving skills and involves abstract thinking. You are supposed to understand your task perfectly and then break it down into a sequence of instructions or smaller computational steps that the computer can execute. For example, John is asked by his boss to do the following. Create a program that adds 10 to any number his boss inputs with the keyboard. The correct reasoning would be, if x is the unknown provided, we need an output of x plus 10. After you have created these steps, with the help of a programming language, you will type in beautifully organized lines of code. So, the second crucial thing to develop is mechanistic thinking. Unfortunately, computers can only execute what you ask them to do, and they won't understand what you imply by the instructions you have provided. They will simply compute the code without interpreting your output. Fortunately, we can do that though. Humans can understand and interpret code instructions and adjust it whenever necessary. And this is why solid knowledge about the syntax of a programming language and the ability to understand computer code is of paramount importance. It will positively affect your thinking process, allowing you to break down your problem into parts the computer can execute. In the example we provided above, John must think of the following subtasks. First, he must define a function that takes x as an argument and then returns as an output a new variable equal to x plus 10. This is how this problem can be solved. Regardless of the problem you are facing or the programming language you are using, your coding style is crucial. Remember that. Having 3 lines of code is straightforward to understand. However, in practice, you will likely work with hundreds of lines of code that must be sent to other people. If your work is difficult to read, unnecessarily complicated, full of variables as names, conveying no meaning, it will be poorly received by other programmers. Therefore, throughout this course, we will pay attention to the best practices that will help you organize your code. Programming challenges are great as they develop your mechanistic thinking and problem-solving abilities. This involves formulating problems, breaking them down into meaningful steps, and communicating these steps to the computer in an organized way. This will do for now. Thank you for watching. Although it may be new to some of you, Python has been on the programming stage for over 2 decades. There are 2 main reasons you should learn Python. First, it has several technical advantages compared to other programming languages. And second, its practical application covers several industries. It is a powerful computational tool when we have to solve complicated tasks in the field of finance, econometrics, economics, data science, and machine learning. Therefore, it is a perfect stepping stone for somebody who learns how to code and is determined to pursue a career as a data scientist. Here's a slightly more technical description of Python. It is an open-source, general-purpose, high-level programming language. Let's break this definition into several pieces and try to understand each of these attributes. Open source means it is free. Python has a large and active scientific community with access to the software's source code and contributes to its continuous development and upgrading. Depending on users' needs, this is the main reason Python is cross-platform. It is available for all major operating systems, Windows, Mac, and Linux. The benefit of it is Python can be quickly applied anywhere. Domain-specific languages like MATLAB and SAS, also used for solving financial and econometric tasks, are paid. This plays a role in a language's popularity. General purpose. Yes, we will dig deeper in one of Python's specific applications, analysis of financial data. However, you should know there's a broad set of fields where it could be applied. For instance, Python can be used for web programming through the Django framework. Although this is beyond the scope of this course, you should be aware of the wide scope of application, and the interoperability with other programming languages could be an explanation why some large organizations have chosen Python as their main programming language. High level. This is slightly more technical. Broadly speaking, computers can run programs written in low-level languages only, also called machine languages. So, a program written in a high-level language must be first interpreted into a low-level language before it can be executed. This process takes time. There is specialized software and applications that will do this interpretation for you. The advantages of using a high-level language are huge. It is difficult to code and understand low-level programming languages. They are too technical. High-level languages employ syntax a lot closer to human logic, which makes the language easier to learn and implement. It allows the programmer to focus on the task at hand, instead of trying to figure out unreadable lines of code. To summarize the technical advantages that make Python a powerful programming language, often preferred over other programming languages, we can say the following. It is free and constantly updated. It can be used in multiple domains. It does not require too much time to process calculations and has an intuitive syntax that allows for complex quantitative computations. What we've said so far demonstrates Python's enormous practical applicability. It is one of the most popular programming languages in several fields. One of them is the world of finance. Just consider, today, banks and financial institutions spend more on technology than any other industry. Thousands of developers work in financial institutions to maintain existing software and build new programs. There is a growing demand for people who have solid knowledge about the world of finance and Python programming. It is clear we are living in the era of big data. People in different disciplines, economics, finance, computer science, marketing, and many more, can retrieve huge amounts of data. We can talk about big data when we have millions of observations. In such situations, the computational capabilities of traditional data processing applications like Microsoft Excel become insufficient. We need a more powerful tool to tackle big data in more or less the same way, regardless of the field application. Python is perfect for these situations, as it gives us flexibility. To conclude, Python's popularity lies on two main pillars. One is that it is an easy-to-learn programming language designed to be highly readable, with a syntax quite clear and intuitive. And the second reason is its user-friendliness does not take away from its strength. Python can execute a variety of complex computations and is one of the most powerful programming languages preferred by specialists. For this course, you must install both Python and Jupyter on your computer. If you have them, you can still complete this lecture, because we will say a few interesting things about Jupyter. So, why isn't there just one software application called Python you can install on your computer that is automatically being updated and that runs everything smoothly? I am sorry to tell you, but it's not the case. We have to deal with reality. First, Python is a programming language. It can allow you to communicate with the computer. To do that, you'll need the help of a specific software or an application. Namely, the Jupyter Notebook app, which is more often called Jupyter, can help us to do that. It is a server-client application that allows you to edit your code through a web browser. Consider the following graph. All units represent different software. On one side, you have several language kernels. These are programs designed to read and execute code in a specific programming language, like Python, R, or Julia. The Jupyter installation always comes with an installed Python kernel, and the other kernels can be installed additionally. On the other side, you have various types of interfaces where you can write code. They represent the clients. An example of such a client is the web browser. The Jupyter server provides the environment where a client is matched with a corresponding language's kernel. In our case, we will focus on Python and a web browser as a client or as an interactive shell. Your work will be stored on a notebook document, and since we will strictly be using the Python language, it will be called IPython Notebook File with the file format .ipynb. Having said all that, we can explain why Jupyter is used in so many large corporations like Google, Microsoft, and IBM. For its design, it is well suited for demonstrations of programming concepts and training. First, in large corporations, solving a particular task could require coding in a few languages, say Python, R, Julia, or PHP. Instead of installing different interfaces for each language kernel you need, Jupyter allows you to use the same structure of the notebook type of file. Simply, each notebook you create will connect to the language kernel you request. Consider also, this file can be easily stored locally or on a remote server. Therefore, Jupyter facilitates the communication between teams in a corporation tremendously. Second, Jupyter is not a text editor that opens a new window every time you execute a different part of your code, as is the case with some other software applications. In the same file, you can have pure text that can communicate a message to the reader, computer code like Python, and output containing rich text like equations, figures, graphs, pictures, and others. This simplifies the process of the workflow immensely, and Jupyter Notebook is increasingly preferred over other software packages. That's why we'll use it too. The next step would be to install Anaconda, a software package that contains both the Python programming language and the Jupyter Notebook app. Thank you for watching.
There are various ways to install Python on your computer. But if you are a new Python user, it is highly recommended to install Anaconda. Anaconda will not only install Python, but also the Jupyter Notebook app, as well as many packages for scientific computing and data science. Let's open www.anaconda.com and click on the download button on the home page. You must pick one of the three operating systems, Windows, Mac, or Linux. In this lesson, I will show you how to install Anaconda on Windows, but the procedure is identical for Mac or Linux. Please keep in mind that, just as any other online service, Anaconda are constantly updating their products and website. So, even if their interface looks slightly different, the functionalities are likely to remain the same. That said, you must then choose one of the four provided options. Which version do you need to install, Python 2 or 3? Do you need a 32-bit or a 64-bit version? The latter will depend on the Windows version you are running. Before we proceed, I'd like to quickly clarify something you might have found curious. Why are there two versions of Python in maintenance at the same time? Well, Python 2 came along first, obviously, and established itself as a very solid programming language in the fields of business, finance, and statistics. It has done its fair share of faithful service, and Python 3 is even better. That's why, during the past few years, the idea has been to switch to using the newer version of the language. The reason for this is that Python 3 has certain advantages that can improve coding, especially in large corporations and professional environments. Looking into these advantages in greater detail, though, is way beyond the scope of this course. In terms of syntax, there are just a few little differences between Python 2 and 3, and we will outline them to you in just a couple of lectures. But for this course in particular, they will be almost insignificant. So, which version should you install? We suggest you install Python 3. It is the newer version and has superior support. Also, by choosing this option, you will be better prepared for the Python version in which you will be coding in the future. And although this course has been presented almost entirely in Python 2, because this was the better option when we were recording, we can assure you that working on Python 3 will not hamper the smooth taking of the course today. The only situation in which installing Python 2 might be preferable is if you are a complete coding beginner. If that is the case, installing Python 2 will enable you to use notebook files containing the same code as the one displayed in the videos. As a matter of fact, we have attached both Python 2 and Python 3 notebook files to all videos throughout the course where providing lecture code was relevant. That's another confirmation that it is not so important which of the two versions you choose to install. Just remember that when you're using the notebook files, you need to use the one stored in the folder that corresponds to the version you've installed. For example, if you access the resources to the lecture on variables and you click on the folder called Python 2, you will see notebook files that will run on Python 2 directly. In the same manner, if you go back and select the Python 3 folder, you will only encounter files that are suitable for working with Python 3. Don't forget that we have kept to this principle throughout the course. It is also valid for the second, financial part of the course, which can as well be taken if you have any of the Python versions. And please, don't pay too much attention to whether you are installing Python 2.6 or 2.7 or 3.6 or 3.7. Newer versions are constantly being released, so the first digit is the only one that matters. Think of it as just Python 2 or 3. Whenever there may be compatibility issues, we will have provided an article with step-by-step instructions on how to deal with them. Having said that, let's go back to the installation process. When you are choosing between a 32 or a 64-bit version, you can simply check your operating system. Newer computers are most likely running with 64-bit processors, but if you would like to clarify this before you begin, you could easily do that. First, open your control panel menu from the Start window. Then select System and check the information referring to the system type. In my case, it is 64-bit, so when I go back to the Anaconda website, I will select the 64-bit Python 3 version, reminding you that the installation process is analogical for Python 2 or a 32-bit version. Then, you must find a directory where to install the distribution and press Save. When the download has finished, run the application. What follows is nothing different from the standard Windows installer. Agree and press Next until you have the chance to specify a destination folder. You could do this after clicking on the Browse button. When satisfied with the indicated directory, click Next one more time. Then follow the suggestions made by the installer. For instance, I will tick the second option only. Finally, click Install and wait until you've been told the operation is complete. That's basically all we needed to install, so I'll skip and untick any suggestions I see after this moment, and will then click on Finish. What you just installed is the whole Anaconda distribution, the Python language, a text editor, mini applications, and packages. You also have the Jupyter Notebook app. You can open the Start menu and select the respective icon from there. A new window will pop up. It will take a few seconds for the app to load. Once this is done, your web browser will open a new tab with the Jupyter dashboard. Bear in mind that there's an alternative for starting Jupyter. You can open the Anaconda Navigator app, which will lead you to all software tools that come with the Anaconda distribution. We are focused on Jupyter only, so if I click on the relevant Launch button, I will once again open a new tab in my web browser. In our next video, we'll study the dashboard in more detail and learn how to use Jupyter. See you there. Thank you for watching.
Okay, so in this lesson, we'll do a quick tour of the Jupyter dashboard. As soon as you load the notebook, the Jupyter dashboard opens. Each file and directory has a checkbox next to it. By clicking and unticking an item, you could manipulate the respective object. That means you can duplicate or shut down a running file. In addition, you can rename and delete folders. The selection menu allows you to select all the files in the console of the same type by expanding this button. For example, you could mark all the folders or all the running files. As long as a file is loaded, Jupyter will call it a running file. In our case, Untitled 1 and Untitled 2 are apparently loaded, since they are marked as running in the right part of the dashboard. Remember, you can have as many running files as you like, and once loaded, a file is considered a running file until you do not specifically shut it down. In addition, you can check this little box that will directly select all the items on the page. The logic regarding the directories management is the same as the one of an operations system. Files can be grouped into folders, and folders can contain other folders. From the Upload button in the top right corner, you can upload a notebook into the directory you are in. The Standard Explorer box opens, and when you select a file, you can click on Open, and it will immediately appear in your directory. Finally, you can expand the New button. From the list that falls, you will most likely need to create a new text file, a new folder, or a new notebook file. A notebook file can contain code in any of the languages in your Notebooks section. When you create a new Python notebook file, it will be recorded in the IPython notebook format, .ipynb for brief. Don't fear this other new name, IPython. Think of it as the predecessor of Jupyter. Consider the IPython notebook format as a legacy file format. All right, let's carry out a few operations. I will rename this folder to Exercises. Okay, done. Now, I will create a new IPython notebook file by expanding the New button and selecting one of the two Python formats I have here. Let's use the default Python format. The browser immediately opens a new tab for me. This is the interactive shell we mentioned earlier. Here, you will write your code and see its output. More on that in our next lecture. Thank you for watching. Okay, great. Now that we know more about the dashboard, we are ready to examine the shell and see how we can code in Jupyter. The field you see here is called a cell. You can access a cell by pressing Enter. Once you've done that, you'll be able to see the cursor, so you can start typing code. The gray box is called Input field. Now, you are in edit mode. The green cell border and the little pencil in the top right corner indicate that as well. To close edit mode, you have to press the Escape button. As I press Escape, I'll go back to command mode, which will allow me to edit the notebook as a whole. This is why the cursor and the pencil disappeared. The cell border turned back to gray and its left margin is blue. Now, I'll press Enter again. I will put a short code that says X is a list composed of 4 numbers, 1, 2, 3, and 4. After that, I can ask the computer to print this list for me by typing X. I can execute these commands in 2 ways. The first one is to hold Control and then press Enter. By doing this, the machine will execute the code in the cell, and I will stay there, meaning I will not have created or selected another cell. Observe that an output field with the same number as the input field appeared. Input and output fields of the same number are grouped together. The output represents the machine's response to your commands provided in the corresponding input, and the respective field cannot be modified. The second option allows for a more fluid code writing. To execute the same code, hold Shift and then press Enter. The previous 2 commands are being executed, and then a new cell where you can write code is created. If you use Shift and Enter, you can continue typing code easily. It is amusing that you can cut, copy, and paste cells. You can use the buttons on the main menu. Since we are keen supporters of ergonomics, we suggest you get used to the keyboard shortcuts. When coding, you will mainly have to use the keyboard, so it's worth memorizing different keyboard combinations that would allow you to work faster. Let's see how we can apply shortcuts in practice. I will cut this cell by selecting it, and then pressing the X key. Remember, you can always use the arrow keys to navigate along your notebook file. So, I will move up and then directly press the V key to paste it. Voila! My cell has moved up here, below the cell I had selected before I pressed the V key. Now, I will press C to copy the same cell. I will use the arrow keys again to go down this time, and at the end, I will press V again. Apparently, this cell was copied and pasted below. The other two buttons in the menu cannot be substituted by keyboard shortcut combinations. They allow you to move a selected cell up or down, just as I am doing right now. Observe that the corresponding output field moves along with its input cell. Lovely! Instead of carrying out a command with Shift and Enter, you might prefer clicking on this button with the mouse. The result will be the same. What is interesting is that when you work with more complex code that requires tougher calculations from the computer, while running the code, a little star will appear over here. Sometimes, this process might take too long to complete, so to stop it or break it, this classical stop symbol can do that for you. 3 other shortcuts could accelerate your coding a lot. Suppose I have selected this cell. After I press the A key, a new empty cell will be inserted above. If I select the same cell and press B, another cell will be created just below. Imagine the last step was a mistake, and I need to delete that empty cell. In this case, it has already been selected, so I can press the D key twice, and it will readily disappear. Wonderful! All the cells we saw so far were code cells. Let's see what is a markdown cell. It is a cell that contains strictly documentation, text not executed as a code. It will contain some message you would like to leave to the reader of the file. To convert a selected cell into a markdown cell, you should either expand this list and opt for Markdown, or simply press the M button. Press Enter to access the cell and type some text. When I run this cell, the output will be a simple statement. Now, if you want to turn a markdown cell back to a code cell, select it and opt for Code from this drop-down menu. Or press the Y key. To conclude, there are 2 advantages of using Jupyter. First, when your code becomes longer, markdown cells turn out to be useful, as they allow you to leave comments and explain the solution you've created. This is why practitioners love to use them. The other benefit of using this app is you can select and execute whichever cell you want to. You need not run all the previous cells to run a particular cell. This allows for solving a problem in pieces and saves a lot of computation time. This was a long but indispensable lesson. We went through everything you need to know before you start coding. From the next section onwards, we will focus on Python. Thank you for watching. There's no doubt it is confusing for newcomers that there's a programming language with 2 actively used versions. And although the world is progressively heading towards solely using Python 3, Python 2 still enjoys an extremely wide scope of application, especially in certain business areas. In the meantime, don't worry if talking about the distinctions between them seems a bit too technical. Now is the right time to introduce this topic, although it will perhaps be understood better when you are more familiar with Python. So, feel free to come back to this video as you advance with the lectures. It's also worth remembering that, while these differences are not unimportant, they will not significantly affect the smooth running of this course. There are only 3 cases where you'll have to change a symbol or two to transfer a Python code from one version to the other. Therefore, we will not delve into a thorough analysis of the programmatic differences between the 2. We will, however, take a look at the syntactical differences which will be visible during the course. The first difference is the use of print. which is a keyword that displays or prints the value of a certain variable. For instance, for a variable z with a value of 100, you will need to type and execute print z if you are using Python 2. In case you are using Python 3, however, you will have to write and run print open parentheses z close parentheses to obtain the same result. The second difference is that Python 2 and 3 divide integers differently. In Python 2, the ratio of two integers is always an integer. For example, 16 divided by 3 will equal 5. Instead, in Python 3, the quotient is converted into a float, so 16 divided by 3 will produce an output of 5.33. Finally, I'd like to mention that we have specifically paid attention to these phenomena in the lectures where we introduce you to the print command and division in Python. Moreover, we have described the relevant differences between the two versions in more detail in the last slides of the course notes, Part 1. This file can be downloaded from the resources section of this lecture, and feel free to proceed with the Python version you prefer. Also, if you have any doubts on this topic, feel free to reach out and we will do our best to solve them. This will do for now. Thank you for watching.
All right, great. Warm up your fingers. In this lesson, we will start coding. One of the main concepts in programming is variables. They are your best friends. You will deal with them all the time. You will use them to store information. They will represent your data input. Let's say you want to have a variable x that is equal to the value of 5, and then ask the computer to tell you the value of that variable. So, we must tell the machine that x equals 5. And this is how you could do this in Python. Type x equals 5. To go through the process of programming, the line that says x equals 5 is called a command or a program. This is just a line of text. To make something out of it, we must execute it. Only then will the computer carry out operations with it. Press Shift and Enter, not just Enter, and a variable called x will be created and assigned with a value of 5. To be more precise, equality in Python and in programming means assign or bind to. Okay, we carry this operation, but we see nothing right now. How can we ask the computer to show us the output of what we just did? It would be sufficient to write x and then press Shift and Enter. And here's the result, 5. Great. As you can see, typing in a single line of code entails a few concepts of programming simultaneously. In the next few lectures, we'll make sure everything falls in place. Now, let's assign the value 8 to a variable we call y. All right, Shift plus Enter, and we can check y. However, I'll type capital Y. Oh, an error. This shows us that Python is case sensitive, so pay attention to that. It matters if you use lowercase or uppercase letters. An alternative way to execute the instruction that will provide the value we assign to y would be to use the print command. At first sight, it seems redundant, as we showed we can just type y. Nevertheless, this command is applied often. You'll see it in most of the code produced by professionals. It complements the logical flow of your instructions. For instance, if we say print y, the machine will simply execute this command and provide the value of y as a statement, and this is all a programmer must see sometimes.
Print exists in Python 3 as well. Its functionality is practically identical to the one just described for Python 2, with the sole difference that here you must place the name of the variable within parentheses. In this case, y. Then you can press Shift and Enter to execute the code in the cell and see that you'll obtain an identical output, the number 8. The difference stems from the fact that Python 3 treats print as a function, while Python 2 rather as a command. But we will not dig deeper into explaining this, as there's a whole section devoted to Python functions, where everything about functions will become much clearer. Therefore, from now on, if you are using Python 3 and you see print followed by a name of a variable, please just add parentheses around the variable name and you'll be good to go. Great! We hope you found this comparison useful. Now, let's continue by talking about Python variables.
The last thing I'd like to share with you in this lecture is you can assign a certain number of values to the same number of variables. To create the variables x and y, we have to assign two values, say 1 and 2. We must separate each of the variables and each of the values with a comma. The parentheses here are not obligatory, but we use them to improve the readability of our code. Now, if I call x or y separately, the computer will correctly give me their respective values. It is very important that the number of variables on that line equals the number of values. Otherwise, you'll get an error message. See? Great! This is a great start to our journey in Python. Make sure you go through the exercises attached to this lecture. We'll see you in the next one. When programming, not only in Python, if you say that a variable has a numeric value, you are being ambiguous. The reason is that numbers can be integers or floating points, also called floats, for instance. Integers are positive or negative whole numbers without a decimal point. Let's create x1 and bind it to the value of 5. Now, x1 is an integer. Do you agree? A specific function in Python can prove this is correct. It is called type. Within the brackets, we must place the name of the variable whose type of value we want to verify. So in this case, I'll type x1. OK. Shift plus Enter, and the result we obtained is int, which indicates the value is an integer. The type function can also be applied directly to a value instead of a variable. For instance, if I write type, open parentheses, -6, close parentheses, Python will correctly point out that -6 is an integer. Good. Now, let's assign the value of 4.75 to a new variable, x2. I would like to check its type. Hence, I will use the type function again. This is a float. Great! Floating points, or as you'll more frequently hear, floats, are real numbers. Hence, they have a decimal point. 4.75 is such a number, therefore, Python reads it as a float. Let's look at two other built-in functions. int transforms the variable into an integer. That's why 4.75 turns into 4. Float, instead, will add a decimal point to the integer value and will turn it into a float. Not all variables should assume numeric values. An example of such type of values is the Boolean type. In Python, this means a true or false value, corresponding to the machine's logic of understanding ones and zeros. On or off, right or wrong, true or false. Let's provide an example with a new variable, x3, which is equal to true. Right. The output of the type function is bool, which simply means x3 is a Boolean. An important detail you should remember is you have to type true or false with capital letters. Otherwise, Python won't recognize your variable as a Boolean and will display an error message. So, to wrap it up, the two Boolean values a variable can have are true or false, and they must be written with capital letters. Thank you for watching.
And welcome back to Python for Finance. In this lesson, we will start talking about strings. But first, I would like to ask you a favor. I would be really grateful if you could go to the course dashboard. That's easy to do. All you have to do is click here and leave a rating for the course. This will mean a lot to me and will help other students know that this course is worth taking. The reason I am asking you to do this now is that this is a large course, and most people do not complete all the lessons in one sitting, eventually forgetting to leave a rating. So, please do it now. It should only take a couple of seconds, and it will really validate our efforts. Thank you so much for this. Okay, now, having said that, let's continue with our introduction to strings. In this lesson, we'll learn about another type of values that can be useful when working in Python. Strings are text values composed of a sequence of characters. Let's see how we can create a string in practice. If we ask the machine to display the name George this way, we'll obtain an error message. Why? Because Python assumes George is the name of a variable to which we have assigned no value. Here's the magic trick that will correct this mistake. Let's type single quotation marks around the name George first. And now, let's type double quotation marks around it. You see the output values of these two inputs are the same. This is how Python displays text results if you don't use the print command. Should you use print, the output will be shown with no quotes. You'll be able to see plain text. If we assign this value to a new variable, let's say x4, we can obtain its output as we did with the integers and floats. Alright, so that's it. If the values you'd like to assign are not numerical, the quotes can come into play. Assume the variable y is supposed to represent the number of dollars you have in your pocket. In addition, you would like to ask the machine to print out a statement that says y dollars, where y is a number. The proper way to combine the value of y and the string dollars is to use a plus sign, as shown here. Let's execute this cell to check if we are missing something. Apparently, we did not respect the rules of coding in Python. We cannot put different types of variables in the same expression. Y is an integer, and dollars is a string. We can convert y into a string. String, str, is the built-in function we need. Analogically to integers and floats, string will convert our number into text, and that will unlock our result. To summarize what we said so far, Python can automatically guess the type of data you are entering. It is within its capabilities to know for sure whether you have assigned an integer, a float, a Boolean, or a string. You need not declare the types of variables explicitly, as you must do in some other programming languages. Python always knows the type of variable. What will happen if you type something like, "I'm fine"? You'll need the apostrophe in the English syntax, not for the Pythonic one. Observe, if you execute the command like this, you will make a mistake. To avoid that, in such situations, you can distinguish between the two symbols. Put the text within double quotes and leave the apostrophe, which technically coincides with the single quote between I and M. Now you are fine. An alternative way to do that would be to leave the quotes on the sides and place a backslash before the apostrophe within the phrase, and we'll still obtain the same correct result. This backslash is called an escape character, as it changes the interpretation of characters immediately after it. And what if we wanted to state press enter, where we put enter within inverted commas? Same logic. The outer symbols must differ from the inner ones. Put single quotes on the sides, and you obtained the desired result. Finally, let's go through a few ways of stating values. Say you wish to print red car on the same line. If I write it like this, two words next to each other, separated by a blank space, I'll see them attached. One trick would be to put a blank space before the second apostrophe of the first word. Let's see. Nice. That looks like the desired result. Another technique would be to sort of add one of the strings to the other by typing in a plus sign between the two, just as we did with the $10 example a minute ago. Okay, as your intuition probably tells you, if you print this combination instead, you'll obtain the same outcome, but it won't have the quotes on the two sides. And here's a new trick. I'll type print red, and then I'll put a comma, which is called a trailing comma, and Python will print the next word, car, on the same line, separating the two words with a blank space. Shift plus Enter. Great. Let's print the number 3 next to the number 5. Boom! Fantastic! Here it is. What will happen if I don't use the print command and just list a few integers, floats, and strings, separating them with commas? Python will execute the command as expected, but will place the values within parentheses. We've made excellent progress, and you've learned a lot about the Pythonic syntax. As we did so far, going step by step perhaps, it looks simple and easy, but it is actually important to respect the syntax of a language while coding. In the next lectures, you see this is true. Stay tuned for the next lesson, where we will continue exploring Python syntax. Thanks for watching. Great! We are making excellent progress. We've covered some of the basics of Python syntax and the way it functions. In this lesson, we'll continue to build our syntax knowledge. We are one step away from covering the essentials, and then we'll be able to dive into more interesting programming tasks. The next topic on our agenda are arithmetic operators. The addition and subtraction signs are straightforward to use. Technically speaking, in the equation you see here, 1 and 2 are called operands, while in the next one, the operands are 3 and 5. The plus and minus signs are called operators, and given they also represent arithmetic operations, they can be called arithmetic operators. Division is more interesting. If we want to divide 15 by 3, we will need to use the / sign. What will happen if we try to divide 16 by 3? 5 again. Yes, the output was 5 because in Python 2, the quotient is an integer by default. Mathematically, if we divide the integer 16 by 3, we will obtain a quotient of 5 and a remainder of 1. If we use real numbers or floats, the float 16 divided by 3 will result in a float value of 5.33. Therefore, we obtained as a quotient the integer 5 and no information regarding the remainder of the division of 16 by 3. This is one of the few substantial differences between Python 2 and 3. In Python 3, you would immediately get 5.33 as an answer, or a float, because the software will understand your first number was a float value. To avoid this, when we use Python 2, we should look for the quotient of the float 16 divided by 3, and not of the integer 16 divided by 3. So, we should either transform the number into a float or type it as a float directly. See? This is the correct answer. Now, let's obtain the remainder of the division of 16 by 3. How can we make Python produce 1 as an output in this cell? The operator that can help us is the percentage sign. I'll type 16 %3, and when I execute the command, I will obtain the remainder. The answer we received is 1. Good. Multiplication. As usual, we can use the star sign when we want to multiply. For example, 5 * 3 will lead us to an output of 15. For the record, you can assign any arithmetic operation to a variable. If we assign 5 times 3 to the variable x and then we call x, we will obtain 15 again. Great! How could you calculate 5 to the power of 3? By using the double star operator. Type 5, 2 stars, 3, and here you go, 125. Easy, right? Okay, basically, this covers arithmetic operators. Stay tuned for the next lesson, where we will explore some other useful operators. Thank you for watching. You know the right way to interpret the equal sign when programming is assign or bind to. For instance, Assign 5 to the power of 3 to the variable y. Bind 5 to the power of 3 to y. This means from that moment for the computer, y will be equal to 125. Here's what will happen when you double the equality sign. Let me type y double equality sign 125. The correct way to read this code is y equals 125. When you run this command, the computer will assume you have requested an answer to the question, is y really equal to 125? This is why, after the execution of this cell, the machine will respond with a Boolean value. It will either return true or false. Let's check our output when we state y is equal to 126. Great! The machine replied with false because 125 and 126 are different numbers. Wonderful! Remember, when you mean equality between values and not assignment of values in Python, you'll need the double equality sign. Anytime you use it, you'll obtain one of the two possible outcomes, true or false. In our next video, we will show you how variables can be reassigned in Python. Thank you for watching. Okay, let me explain a programming concept that is valid for other programming languages as well. If I assign the value of 1 to a variable z, my output after executing z will be 1. After that, if I assign 3 to the same variable z, z will be equal to 3, not 1 anymore. How come? Well, the order of the commands matters. Initially, we said z will be equal to 1, and that was true, until we changed the value to 3. For the computer, from that moment on, z is not equal to 1, and it will continue to be 3. As proof, see this. If we add 5 to z, we will get 8. Not 1 plus 5, which is equal to 6. Then, if we suddenly decide z is equal to 7, z will not be equal to 1 or 3 anymore. Python reassigns values to its objects. Therefore, remember the last command is valid, and older commands are overwritten. Thanks for watching. Especially when your code becomes longer, and by longer, I mean containing tens or hundreds of rows, it becomes difficult to understand how your work has been structured because there are too many lines. What you could do in these situations is leave a comment. Comments are sentences not executed by the computer. It doesn't read them as instructions. The trick is to put a hash sign at the beginning of each line you would like to insert as a comment. I'll improvise with a random sentence. It is just a comment and not code. Execute with Shift and Enter. When you run this cell, there will be no output because the comment does not count as code.
Let's add code. Print, open parentheses, 7, comma, 2, close parentheses. Execute with Shift and Enter. Yes, precisely. We got 7 and 2 on the same line, and the comment row marked with a hashtag produced no output. It remained visible only to the programmer. The computer executed the print command only. If we would like to leave a comment on 2 lines, don't forget to place the hash sign at the beginning of each line. These 2 will be comments. Everything seems to work.
Okay, perfect. I'd like to show you a neat trick that will be extremely valuable when you become an advanced Python programmer and work with large amounts of code. This is a very handy feature, so please pay attention. Sometimes the length of the cell will not suffice for you to finish your line. Lines of code could get long. Or, just for the matter of organizing your code, you might prefer to send part of the code to the next line. So, 2.0 times 1.5 plus 5 could be written in 2 lines, and the machine could still read it as one command. This could be achieved by putting a backslash where you would like the end of the first line to be. It indicates you will continue the same command on a new line. Cool, right? All right, great. Let's look at another important concept that will help us a great deal when working in Python: indexing. This is a technique we'll use frequently later in the course, especially when we focus on Python's application in the world of finance. So, here's an example of how indexing works. The word Friday is written here, right? Is it possible to extract the letter D? Yes, we can do that by using square brackets, and within them, we should specify the position of the letter we would like to be extracted. A very important thing you should remember is that in Python, we count from 0, not from 1. 0, 1, 2, 3, 4, and so on. That's why I'll ask for the fourth letter, D, by writing 3 here. See? And we obtain the letter D. Had we put 4, we would have obtained the letter A. This is the syntax in this occasion. Square brackets right after the word, or the string of characters if you wish, and a number indicating the position of interest. This is how indexing works in Python. Thanks for watching. The next concept for programming in Python we will see here is fundamental. It is called indentation. The way you apply it in practice is important, as this will be the only way to communicate your ideas to the machine properly. Here is what I mean. Let's define a function, 5, that takes as an argument an unknown x. It will be a simple one. X will be reassigned the value of 5, and the function will return the value of 5 for us. Please note that I am using an indent. Now, we can print the result of 5 with an argument of 3. Nothing happened. Why? Because printing 5 of 3 is within a function, so it will be executed only when the function is applied. If we place print on a new line instead, aligned to the def command, the output will be different. How come? The print command is executed on its own, not as part of the 5 function. Def and print form two separate and written in this way, clearly distinguishable blocks of code or blocks of commands. It makes sense to use indentation, doesn't it? Everything that regards the function is written with one indentation to the inside. Once you decide to code something else, start on a new line with no indentation. The blocks of code are more visible, and this clarifies the logic you are applying to solve your problem. Working with functions is interesting, right? Keep up the good work, and I promise to come back to that soon. All right, excellent. You are familiar with the main syntax in Python, and that will help you in the next lessons. In this section, we will learn more about the operators that will help us in our work in Python. We will start with comparison operators. We said if we type the equality sign twice, we can verify the left and right side of an equality are equal. Well, if we use an exclamation mark and an equality sign, then we could verify if two sides are not equal. So, it would be false to say 10 is not equal to 10. And it will be true that 10 is not equal to 15. If we use an exclamation mark and equal, and the two sides we are comparing are 10 and 15, we'll obtain true, as we wanted to verify they are not equal. Good. What is next? Greater than and less than. We can use the well-known symbols to test if a value is greater or smaller than another value. Is 100 greater than 50? Yes, it is. Is it smaller? No, it is not. And that's why we get false. That's great. The logic behind checking whether an operand is greater than or equal to and less than or equal to is the same. Don't forget that on the right side of the operand, we are not limited to providing only one number, like 10. We could insert an expression, like 10 plus 10. So is 15 greater than or equal to 10 plus 10? No. Is 15 less than or equal to 10 plus 5? Well, that is true. Great. This covers everything we can possibly say about comparison operators. Now, let's see what is intended with the expression logical operators, also known as Boolean operators. Briefly, the logical operators in Python are the words not, and or. They compare a certain amount of statements and return Boolean values, true or false, hence their second name, Boolean operators. Let's start by providing an example with and. And checks whether the two statements around it are true. Let's use only the Boolean values true and false for now. True and true will result in true, while true and false gives an answer, false. False and false will naturally bring us to false. Okay. Or checks whether at least one of the two statements is true, hence false or false will come back as a false, whilst true or true will return true. In this cell, true or false will return true. The order in which we have the two statements does not matter, so false or true will still result in true as well. The way not functions is it leads to the opposite of the given statement. Not true leads to false. Not false leads to true. Let's see a slightly different example. The idea is to show you in this cell that the Boolean operators can be applied not only to Boolean values. The statement 3 greater than 5 is false, while 10 less than or equal to 20 is true. False and true entails false. And this is what we obtained. Good. The fun starts when you combine these logical operators. In these occasions, you must respect the order of importance of these three operators. It is not comes first, then we have and finally or. The examples in these three cells will help you get the right intuition. In the command true and not true, we should first consider what the operator not will do. It will be applied to the value true, and not true means false. Therefore, what's written in this cell must be interpreted as true and false. Now, the remaining operator and can be applied. True and false leads us to false. The answer is correct, false. Let's do an example with all three Boolean operators, false or not true and true. False or not true and true logically is the same as false or false and true, because before anything else, not true must be read as false. Then and has an advantage over or. This is why we will concentrate on the phrase false and true. Its outcome is false. We are now left with false or false. Both values are false, which always leads to false. As expected, false. To solidify the concept, let's go through another similar example. True and not true or true is the same as true and false or true, because initially, not mattered most. Now, and will convert true and false to false. Now, we can think about the remaining false or true, because the or operator needs at least one true statement to return true. Our result after running this cell will be true. Great! Let's see what identity operators are about. The identity operators are the words is and is not. They function similar to the double equality sign and the exclamation mark and equality sign we saw earlier. Let's illustrate their application with the following examples. If we say 5 is 6, we'll immediately understand it is false. The same as if we wrote it like this, with the double equality sign. If we said 5 is not 6, that'd be true. And it will be the same as if we wrote 5 equals 6. Great! You have learned a lot about operators in Python and about its syntax. It is the right moment to dive into something more interesting. Starting from our next lesson, we'll deal with a topic that is a big part of a programmer's everyday life: conditionals. You are prepared to dig deeper, so do the exercises and see you in our next video. Thank you for watching. In the previous lectures, you saw how you can assign different values to a variable. In this lecture, you will see values act as the most basic or primitive data elements necessary to form not only variables, but any expressions. A prominent example of conditional statements in Python is the if statement. What you can use it for is intuitive, but it is very important to learn the syntax. Think of the following. If 5 equals 15 divided by 3, then print hooray. First, don't forget we should use the double equality sign here, because we are checking whether 5 is equal to 15 divided by 3, and we are not assigning the value of 15 divided by 3 to be 5. 5 is not a variable name. It is a number. Good. Now, it is crucial to place a colon. The colon will tell the computer what to do if the condition we just wrote has been satisfied. For achieving good legibility, we advise you to write the print statement on a new line. Please remember, it should be indented. Otherwise, you will run into an error. All right. Now this should work correctly. Yes, 5 is equal to 15 divided by 3. Hooray! Will it work if we check for 5 being equal to 18 divided by 3? It is not supposed to, since 5 differs from 6. We got nothing, because we have not told the machine what to do if the provided condition is not satisfied. So, there is no reason for the machine to print out hooray. The graph could help you imagine the process of the conditionals. Before it displays the outcome of the operation, the machine follows these logical steps. If the conditional code is not to be executed because of the if condition is not true, our program will directly lead us to some other output, or, as it is in this case, to nothing. After any of the two situations, the machine will go to the next black point and will progress from there on. Let's try with an inequality sign, which can be written with an exclamation mark and an equal sign. Isn't 5 different from 3 times 6? Yes, it is. It is true that it is different. Hence, we have hooray as an output. This was a brief introduction to if statements. This logic will help you proceed to the next lecture, where we will complicate things a little bit, but not too much. Thank you for watching. Okay, let's assign the value of 1 to x. We can ask the computer to display case 1 if x is greater than 3, and case 2 if it is less than or equal to 3. Okay, we could write two if statements one after the other. Let's see if we get the correct outcome. Yes, we are in case 2. There is a shorter and better way to express ourselves here. In the second part, instead of saying if x is smaller than or equal to 3, we could write directly else : Else will tell the computer to execute the successive command in all other cases. In our little program, that would mean in all cases when x is not greater than 3. That translates into when x is less than or equal to 3. Let's verify if what we did was correct. Bingo! Case number 2.
This picture adds up to the one we saw in the previous lesson. Instead of leading to no output, if the condition is false, we will get to an else code. In our case, this is the print function with the string case2 as an argument, written in parentheses. Regardless of whether the initial condition is satisfied, we will get to the endpoint. So the computer has concluded the entire operation and is ready to execute a new one. Wonderful! Now, please allow me to share 2 notes on the subject. Don't fall into the trap of organizing your code on a whim. There is a strict manner to do that, and indentation plays a key role again. Should you put the else keyword just underneath the first print word, nothing will happen. Remember to place the if and the else keywords on the same vertical line. This is the right moment to introduce you to the notion of blocks of code. The if statement, meaning the condition plus the relevant print function, forms the first block of code. The entire else statement forms another block of code on its own. Therefore, in a long sheet with much code, you'll have a whole lot of blocks. And larger programs are constructed on a block-by-block basis.
We are ready to look at elif statements. Thanks, and see you in the next video. In this lesson, we'll learn an elegant way of adding a second if statement to one of our expressions. This is done with the help of the elif keyword, as shown in this example. If y is not greater than 5, the computer will think, else if y is less than 5, written elif y is less than 5. Then I will print out less. And the else statement follows as a tail with the respective block that says return equal. Let's confirm we wrote the code correctly. We can print out the compare to 5 function with a value of y equal to 10 in the following way. Then we'll expect to see a statement that says greater because 10 is greater than 5. Correct? Okay, perfect. What if we carry out this operation for the number 2? The machine tells us that 2 is less than 5, and that's what we expected. To obtain the third outcome, we must compare the number 5 with a number that is not greater or smaller than 5. This will happen only if the argument of the function is 5, right? Shall we try this one? Great! We obtained equal as expected. Know that you can add as many elif statements as you need. Let's provide an example. If y is less than 0, the string negative should be displayed. I will place the block between the if and the other elif statement. Let's see what happens. The function with an argument of -3 shows negative, just as it should. Let me just control whether our little program will run properly if I asked it to compare to 5, a value that lies in the range between 0 and 5, say 3. Yes, we see less, so everything is okay. A very important detail you should try to remember is the computer always reads your commands from top to bottom. Regardless of the speed at which it works, it executes only one command at a time. Scientifically speaking, the instructions we give to the machine are part of a control flow. This is something like the flow of the logical thought of the computer, the way the computer thinks, step by step, executing the steps in a rigid order. When it works with a conditional statement, the computer's task will be to execute a specific command once a certain condition has been satisfied. It will read your commands from the if statement at the top, through the elif statements in the middle, to the else statement at the end. The first moment the machine finds a satisfied condition, it will print the respective output and will execute no other part of the code from this conditional. In our example, if the first statement is correct, we will see the corresponding output number 1. which is printing the string greater. The computer will disregard the elif and the else statements and will proceed with the rest of the code. If the first statement is not correct, we will move forward, and the computer will check whether our second statement is true. If yes, we will see output number 2, which is printing the string negative. If not, we will get to statement number 3 and so on until the computer finds a satisfactory outcome to print out. Now, I will switch the order of the two elif statements to prove that the order of instructions matters, okay? Let me print compare to 5 of minus 3. Ha! Instead of negative, we obtained less. This is how the computer reasons. Assume y equals minus 3. Print out greater if y is greater than 5. Is it greater than 5? No. So the computer continues and checks if there are any other statements in our code. Given we have other statements, it moves forward. So is y less than 5? Yes, it is. At this moment, the computer thinks, lovely, I got it. My number is less than 5. I satisfy what my programmer asked me to do. I print out less and I am fine. And the machine stops there and does not execute a single letter of the code that follows in this block. The fact that you examine the cases when y is less than 0 or equal precisely to 5 have no application. They become useless. Whether you ask for the output of minus 3 or 3, you will still have to be satisfied with the less label. You found this interesting, didn't you? Stay focused for the next lecture, when we will share something more about computational logic. Thank you for watching. You probably noticed we talked about Boolean values a few times. Here, we would like to provide a short video that aims to explain their application. Let x be equal to 2. What you see next is the following if-else construction. If the value of the x variable is greater than 4, print out correct. In all other cases, print incorrect. So, which is the Boolean element we have in this computational logic? Basically, after you insert your if statement, the computer will attach a Boolean value to it. Depending on the value of its outcome, true or false, it will produce one of the suggested outputs, correct or incorrect. If the first statement is true, that is, if x is greater than 4, the machine will print the corresponding statement, correct. Else, which means if the statement x greater than 4 is untrue, or more precisely, false, the statement incorrect will be printed. From a certain perspective, everything in a computer system is Boolean, comprising sequences of zeros and ones, false and true. This is why we are paying attention to the Boolean value. It helps us understand general computational logic and the way conditionals work in Python. Okay, excellent. We can wrap it up here. This wasn't an easy section, right? But you learned a lot and are making a great progress. Now you know more about conditionals in Python, and you understand the control flow of if, elif, and else statements. In addition, you saw once more complying with the Pythonic syntax is crucial for the execution of your code. Where you type the colon sign and indentation matters. Last, you saw the order in which you declare your commands leads to a specific outcome. If you change the order of your commands, the outcome could change, and this may take you to undesired results. Wonderful! In our next section, we'll dive into the world of Python functions. See you there, and thanks for watching. Great! Let's step it up a notch. Starting from this lesson, we'll deal with Python's functions as an invaluable tool for programmers. The best way of learning is by doing, so let's create a function and see how it can be applied. To tell the computer you are about to create a function, just write def at the beginning of the line. Def is neither a command nor a function. It is a keyword. To indicate this, Jupyter will automatically change its font color to green. Then you can type the name of the function you will use. For instance, simple, as we will create a very simple function. Then we can add a pair of parentheses. Technically, within these parentheses, you could place the parameters of the function if it requires you to have any. It is no problem to have a function with 0 parameters. This is the case with the function we are creating right now. To proceed, don't miss to put a colon after the name of the function. Since it is inconvenient to continue on the same line when the function becomes longer, it is much better to build the habit of laying the instructions on a new line with an indent again. Good legibility counts for a good style of coding. All right, let's see what will happen when we ask the machine to print a sentence. Not much, at least for now. The computer created the function simple that can print out my first function, but that was all. To apply the function, we must call it. We must ask the function to do its job. So, we will obtain its result once we type its name, simple, and parentheses. See? Great! This will do for now. Thanks for watching. Okay, good. Our next task will be to create a function with a parameter. Let it be plus 10 with a parameter a. That gives us the sum of a and 10 as a result. Always begin with the def keyword. Then type the name of the function, plus 10, and in parentheses, designate the parameter a. The last thing to write on this line would be the colon sign. Good. What comes next is very important. Don't forget to return a value from the function. If we look at the function we wrote in the previous lesson, there was no value to return it. It printed a certain statement. Things are different here. We will need this function to do a specific calculation for us and not just print something. Type return a plus 10. This will be the body of this function. Now, let's call plus 10 with an argument 2 specified in parentheses. Amazing! It works! Once we've created a function, we can run it repeatedly, changing its argument. I could run plus 10 with an argument of 5, and this time the answer will be 15. Great! Pay attention to the following. When we define a function, we specify in parentheses a parameter. In the plus 10 function, a is a parameter. Later, when we call this function, it is correct to say we provide an argument, not a parameter. So we can say call plus 10 with an argument of 2, call plus 10 with an argument of 5. People often confuse print and return and the type of situations when we can apply them. To understand the concept better, try to imagine the following. There is an argument x which serves as an input in a function, like the one we have here. The function in this case is x plus 10. Given that x is an input, we can think of it as a value we already know. So the combination of x and the function will give us the output value y. Well, in programming, return regards the value of y. It just says to the machine, after the operations executed by the function f, return me to the value of y. Return plays a connection between the second and the third step of the process. In other words, a function can take an input of one or more variables and return a single output composed of one or more values. This is why return can be used only once in a function. Therefore, we can say the concept of a function applies to programming almost perfectly. There are some extra advantages to consider. You could also assign a more intuitive name to a function, plus 10 or addition of 10, and the function will still run correctly. This is a sign of good design. On a sheet with 1,000 lines of code, if you call all your functions x1, x2, x3, and so on, your colleagues will be confused and utterly unhappy. Naming functions clearly and concisely makes your programming code easy to understand, and it will be accepted as one of good style. There is another way in which you could organize the definition of your function. Start by defining plus 10 with an argument of a and a colon. On the next line, instead of directly returning the value of a plus 10, another variable can be created inside the function to carry that value. I will use the name result here. I will assign it with the desired value of a plus 10. Let's check what we just did. If I execute the code in the cell, I will get nothing. Why? Because of this moment, I have only declared the variable result in the body of our function. Naturally, to obtain the desired outcome, I will also have to return that variable. See? When I call plus 10 with an argument of 2, I obtain 12. It is all fine again. Print takes a statement, or better, an object, and provides it printed representation in the output cell. It just makes a certain statement visible to the programmer. A good reason to do that would be when you have a huge amount of code and you want to see the intermediary steps of your program printed out, so you can follow the control flow. Otherwise, print does not affect the calculation of the output. Differently, return does not visualize the output. It specifies what a certain function is supposed to give back. It's important you understand what each of the two keywords does. This will help you a great deal when working with functions. The following could be helpful. Let the same function also print out the statement outcome. If we put down only return outcome and then return result, what will we get when we call the function? Just the first object to return, the statement outcome. If, instead, we print the statement and then return result, we will get what we wanted, the outcome statement and the result of the calculation, 12. This was to show you we can return only a single result out of a function. This will do for now. Thank you for watching. It isn't a secret, we can have a function within the function. For instance, let's define a function called wage that calculates your daily wage. Say you use working hours as a parameter, and you are paid $25 per hour. So, this should work. Okay, good. Notice, I don't technically need the print command here. I could print out the wage afterwards, but I don't really need to. So, I'll proceed this way, just returning the value I need. When you do well in a day, your boss will be very happy to give a bonus of $50 added to your salary. Hence, I'll define a with bonus function for you. And, as a parameter, I will take again the working hours. But this time, I will allow myself to return directly the wage with working hours as an output, which would be the value obtained after the wage function has been run, plus the extra $50 you've earned. This is how the first function is involved in the output of the second one, a function within the function. Let's see what the output will be if you worked 8 hours today and the boss was very happy with your performance. Wage with an argument 8 and with bonus with an argument of 8. Great! 200 of base compensation and $250 with the bonus. Don't forget to do the exercises after this lecture. This is the best way to reinforce what you've learned. We know how to work with if statements, and we know how to work with functions. In this lesson, we'll learn how to combine the two. This is a fundamental concept in programming, so please pay attention. You'll encounter it quite regularly when coding. Johnny's mom told him that, by the end of the week, if he has saved at least $100, she would give him an extra $10. If he did not manage to save at least $100, though, she would prefer not to give him the extra cash. Clear? Now, let's define a function called add10, which takes as a parameter the unknown m that represents the money Johnny saved by the end of the week. What should we tell the computer to do? If m is greater than or equal to 100, then add 10 to the saved amount. If it is not, return a statement that lets us know Johnny should save more. That is, if m is greater than or equal to 100, let m assume the value of m plus 10. Yes, it is what you saw. We have m on both sides of the equation, and that is perfectly fine. As a matter of fact, it is not an equation. Remember that the equality sign stands for assigning the expression on the right side to what is written on the left side. Let's complete the if part with return m. To sum up, logically, we mention m as a parameter. Then, we substitute its value with a greater value than m with 10. At the end, we say, from now on, return a value equal to the new m. Finally, in all other cases, for instance, save more. Johnny should learn it is a good habit to have some cash on the side, right? Let's see if our intuition was correct. Add 10 of 110. Good, 120. And if m was equal to 50, amazing! Everything is correct. When you think of it from a logical perspective, it makes sense, doesn't it? What would you use a computer for? To solve problems for you. And it can do that through functions. You'll most probably need to ask the machine to execute something if a given parameter is within certain limits, and ask it to execute another thing if the parameter is beyond these limits. Therefore, combining your knowledge about conditionals and functions in Python comes right on the money. Great! Just keep the pace for our next video. Thank you for watching. We are almost there. In this lesson, we'll learn how to work with more than one parameter in a function. The way this is done in Python is by enlisting all the arguments within the parentheses, separated by a comma. Shall I call the function we have here for, say, 10, 3, and 2? I get 4. Seems easy to add a few parameters, right? And it is. Just be careful with the order in which you state their values. In our case, I assign 10 to the variable a, 3 to b, and 2 to c. Otherwise, the order won't matter if and only if you specify the names of the variables within the parentheses like this. b equals 3, a equals 10, and c equals 2. And of course, we could obtain the same answer. 4. This is how we can work with functions that have multiple arguments. Awesome! Let's see what's next. When you install Python on your computer, you are also installing some of its built-in functions. This means you won't need to type their code every time you use them. These functions are already on your computer and can be applied directly. As a matter of fact, you saw examples of built-in functions in the lesson about data types. The function type allows you to obtain the type of variable you use as an argument. Like in this cell. Type of 10 gives int for integer. The int, float, and string functions transform their arguments in an integer, float, and string data type, respectively. This is why 5.0 was converted to 5, 3 was converted to 3.0, and the number 500 became text. Great! Now, let me show you a few other built-in functions that are quite useful. Max returns the highest value from a sequence of numbers. This is why Max returned a value of 30 as an output in his cell. Good. Min does just the opposite. It returns the lowest value from a sequence. So, we get 10 in that cell over here. It is the smallest among 10, 20, and 30. Another built-in function, abs, allows you to obtain the absolute value of its argument. Let z be equal to minus 20. If we apply the abs function to z, the result will be its absolute value of 20. See? Perfect! An essential function that can help you a great deal is sum. It will calculate the sum of all the elements in a list designated as an argument. Consider the following list made of 1, 2, 3, and 4 as its data. When I type SUMLIST1, my output will be equal to 1 plus 2 plus 3 plus 4. The sum of these numbers equals 10. Round returns the float of its argument, rounded to a specified number of digits after the decimal point. Round 3.555 with 2 digits after the decimal point will turn into 3.56. If the number of digits is not indicated, it defaults to 0. 3.2 is rounded down to 3.0. Great! If you are interested in elevating 2 to the power of 10, you know you could type 2 $10. You can get the same result if you use the PAL function, which stands for power. Write PAL, and in the parentheses, specify the base and the power, separated by a comma. In our case, 2, 10. Execute with Shift and Enter, and voila! 1024. And what if you wanted to see how many elements there are in an object? The len function, as in length, is going to help you do that. If you choose a string as an argument, the len function will tell you how many characters there are in a word. For instance, in the word mathematics, we have 11 characters. There are many other built-in functions in Python, but these are a few examples you will often need to use when programming. Thank you for watching.